Well, I don't need an introduction, I don't think, but I do want to mention at the outset that I found this hard going to prepare a talk on overpopulation because it's it gives an impression, it's accurate, but um, not totally forward thinking, and I'll explain that as we go ahead. It's a difficult issue to talk about. There are a lot of emotional issues as well, but I'll do my best. And then about halfway through, I will pick one of the biggest problems we have, and that's why I put in the green letters there. Can high tech help? I think high tech can help, and I'm not thinking of birth control here, but I'm thinking of other issues that I'll talk about. And did you just let Ellen in?
I did.
Good, thank you. So you'll be staying on a few minutes more?
Oh, sure. Yep.
Thanks so much. I
No
appreciate it.
worries. You betcha.
Okay, well, let me get started then. I draw your attention to the right side of the panel and emphasize the second word, minute, every minute. So as I'm talking here, just in a minute, 157 new people join the world's population. And of those 157, 4 are in the developed countries. Similar numbers are born and die, but a difference of 4. And then in the developing countries, I haven't defined them here, but we have an idea. I'm not going to go through the list, but we'll talk a little bit about it as we go through. 153 are from developing nations, and the huge difference between babies born, 237 versus 83 people dying. So it's generally a younger population, and a large number of babies are being born every minute. So that's a thought to keep in mind as we try and deal with the issues. This graph is interesting one. It looks at 6,000 years history of our species, and it looks at the total world population, past, present, and future, and puts in some pointers about what happened along the way. With this huge increase on the right, it looks like an aberrant species, and the population growth is the root cause of today's climate and ecosystem catastrophe. We don't deal with it very much. We talk about it as the silent elephant in the room, but ultimately it does contribute to consumption, and technology just have not been able to keep up very well. It kept us from starving many times, but still has not stopped the decimation of the planet. We see these lovely scenes on travelogues and so on and often on adventures that we see on Netflix and other programs of people living in the Great Northwest. But for those of us here in the Midwest, we see that the fields around us here in Wisconsin, cornfields and other fields, are rapidly being consumed by new homes. It's a very popular place in the Midwest for people to come and live. And so we see this evidence of population growth and technology all contributing. There is a number of people, famous ecobiologists have said that it would be ideal if we had 2 billion people. So that would take us back to the time of the beginning of the previous century. We were at 1.2 billion. And they say the planet was okay then, and it would be okay if we got down there. But the problem, as I'll allude to later, is once we get up and plateau, we're going to be coming down at a pretty fast rate too. How can we be sure we're going to level off there at 2? So it's in dealing with our first speaker, Peter Fikowski. This is a quote from him. He didn't show up, but he did write an interesting book called Climate Restoration. And he said, without taking draconian steps, we could promote family planning to follow the 45 countries that now have birth rates of 1.6 or less. And I think that's a true statement. I think he's pretty optimistic in all of his thoughts, but that's at least a positive statement. This slide you've seen before. I've shown it a couple of times. The thing to notice is the shading. Low impact on the left, moderate impact here in the middle, and high impact on the right. And we've learned that although recycling is important, or hanging your clothes out to dry would save some fossil fuels, I thought it was kind of interesting that if we avoided one round trip, transatlantic, or for some of you listening, trans-Pacific flights, that would do quite a bit. And we have here on the ordinate the annual climate savings in tons of CO2 equivalent. So that would be as good as buying green energy, or switching to an electric car or something like that. Living totally car-free is a good thing, but way over here on the right is having one fewer child. And notice that the scale changes here from 4, it jumps up 5-fold in the next division and goes on up to 60. So it's a huge impact just having one fewer child. It's all very well for us. We're mostly grandparents, a little late to be influencing that number, but sometimes we can be talking to great-grandchildren or something like that to let them know that there is a significant impact of having an extra child. This image came to me from Alex Canara, who's a mathematician out in Stanford. And I make a comment on the left. Naomi Oreskes says, having more people will not solve our population problem. Well, that's for sure. Worldwide, 100 million unintended pregnancies happen, most of which are aborted, and outlawing abortion just makes it unsafe. Doesn't change the picture very much. Also, they talk about this one on the right here. The main image was put out by Metallurgy and Exploration Foundation, and all these various metals, salt, clay, zinc, gold, all these different metals. Alex Canara is circled to fuels, and he circled coal, fuels in general, natural gas, petroleum, and pointed out that 1 kilogram of uranium or thorium could replace all these pounds or large numbers of pounds of fuel, coal here, and natural gas and petroleum. So if we chose to do it, we'll get to that later, but it's a good point. And the more children, the more plastic. A lot of diapers and children's, infants, toys and other things. And we're dumping 11 million metric tons into the oceans per year. It's not only getting as microplastics in the water, but it's now in the air. So we need to deal with manufacture of plastics as well as gathering them up. Globally, we're really not accomplishing very much in terms of CO2 emissions. This is a reasonably current graph that goes from 1950 to 2020. We're following. EU is doing a better job than we are. We were right with them up until 1985 or so, and they've been able to improve and cut their emissions, but we've not been as effective. One of the things that they've done, and I'm of course put in a plug for France, with which I'm more familiar, their electric train, rapid transit train, has been so effective that they've cut back tremendously Air France and other domestic airlines, encouraging people to take the train, and they can travel, as I've done over there, on electric trains that are 78% powered by nuclear energy, at tremendous speeds of approaching 200 miles an hour, and your wine glass doesn't even vibrate. The tracks are welded, there are no level crossings, and they really learned about local transportation. It's a little tougher to do that in a bigger country like the United States, but there are other reasons why we've not been as effective. We're still talking about it along certain corridors, but and we might achieve it, but it'll take another bit for us to get to 78% nuclear. That would be wonderful. Globally, though, which is the point of the graph, we've not been doing very well. They just say China emitted 31% versus our 13%. This is not a per person basis. This is a per country. And we have allowed China to take a lot of our industry. So those numbers, I think, will moderate somewhat in the future, but we can, I think China will succeed in cutting back their emissions, as I'll show you in a few slides later. Our rate of population growth is not peaking yet, is the point. And this is an interesting curve because it shows this relatively linear curve of world population in billions. And we crossed 8 billion just a year ago. November the 15th, 2022 was called the Day of 8 billion. And it marked its estimate that humanity has reached another billion milestone. They expect it to project it will exceed 10 billion. Here is 10. And the UN has 95% confidence that that will happen. There's a health metrics evaluation in Seattle, and they think we can just narrowly miss that. And I'll deal with that one a little bit later. But it took us, the point of the slide is it took us only 12 years to add that extra billion people. And our future hinges on how we tackle climate change. We don't know exactly how we're going to tackle that. It depends a lot on decisions yet to be made. We expect to temper things with better technology, but that gain may be lessened or eliminated entirely by the needs of our continuing overpopulation problem. We've talked about electric vehicles several times, including, I think it was last week. And I think it's interesting that electric vehicles had a certain cachet, but then people began to have a lot of range anxiety. We talked about that. And so they pushed SUVs, but not just pushed SUVs, they made them bigger and heavier. And a lot of people who just have no interest in cutting back emissions have gleefully taken these great big SUVs and driving around merrily with them. They have enough money in the bank to pay for the extra gas and they don't care. But the point of this paragraph is that we need to mentally be concerned about the planet and try and take it as our responsibility to reduce our emissions. Seattle's Institute for Health Metrics that I talked about sees us peaking, as I mentioned, at 9.7 billion. And they think that won't happen right away, that it'll be 2064. That's quite a ways away, but dropping to 8.8 billion by the end of the century. Let's go back to this last slide. So there we are here, the end of the century, and it'll drop. So that's that red line there. It's an interesting point of view. I have a little more faith in it than I do in the UN, but they say that future projections are vague, that it's hard to assess climate impacts, how much that will, not so much the climate severity, but the impact that will have on the emotions of people and also the effects of tipping points, such as methane release, that we haven't yet figured. In this cloud, you can see here underneath, you can see Calcutta, I think, and Dakar. In this Indian continent here, a lot of heat, extreme heat, is making India uninhabitable. How will people respond to sea level rise and heavily populated? A lot of these are unknowns. We just don't know how well India is going to respond, let alone Pakistan. This is the epicenter of a new global wave of disease and death linked to climate change. And the Washington Post thinks that leading scientific studies, interviews with experts show that Pakistan here will bear the brunt of Earth's heating. This examination of climate-fueled illnesses tied to hotter temperatures and swift passage of pathogens and toxins shows that countries around the globe are ill-prepared for this insidious intensifying risk of almost every facet of human health. I don't know if any of you watched the NewsHour on Friday night, but Jonathan Capehart was, among others, talking about what they were thankful for. And many people, logically, were thinking, were appreciating their families and the idea of family togetherness at a time like Thanksgiving. And Jonathan, being gay and perhaps not having a family, is decided to be thankful for science. And then he elaborated on that by saying that he just got COVID the other day, and it was just a little sniffle. And he realized that if it hadn't been for science, it would have been a lot worse for him. So I appreciated his appreciation of science. Certainly important. China has a very different situation. This year, for the first time, China will no longer be our most populous country. The birth rate dropped in half in the 1970s. I visited China in 2004 and noticed that their one-child policy, which supposedly took over in 1980, only happened in the major cities, was not influencing people in the country at all. With the recent pandemic, their birth rate is now lower than ours, while their population ages. In contrast, India overtook China just this year. Both countries now have 1.4 billion. And on the eve of Diwali, which is a Hindu festival of lights, people crowded at market in Bangalore, and I just used that photo to show the large population there. Our species has been successful in feeding itself so far, but climate change can add powerful new threats to that, and we are getting concerned. The United Nations did make this interesting map showing huge variations. The key here is up in the upper right, where things in pale purple or soft gray are within 5% of no change. But as you get further and further into the green and dark green, you get large areas where population change is still really happening a lot. And I'll elaborate on that in a few minutes. This is an example in Nigeria. I thought this is from the National Geographic, came out a few months ago in Lagos, Nigeria. Emmanuel and Nawaigo and Wanike have lived in this single room with their 4 children for 11 years. And that is something to imagine. 6 people in one room, no running water, intermittent electricity. I'm not sure if this is a TV or an aquarium on the side here, but they look like a happy family in this photo. But more than 1/3 of Nigeria's people live in extreme poverty like this. The birth rate there is 20 times the birth rate in China. And again, consistent with the figure that we just saw. Homes on the edge. This is a part of Africa around the tucked into the corner near Nigeria, Benin, and the rivers there just merge into the ocean. And people are accustomed, as you can see, with little lines here drawn around, suggesting that there's doing some fishing, some netting, one thing and another. But when the typhoons come or the floods rain, because the glaciers in the Himalayas are, well, not Himalayas for Africa, but anyway, some of the Kilimanjaro perhaps, when they have the changes in the climate that lead to more sudden onrushes of water, these people will be in dire straits. The Congo forests provide food and income, and really a close second to Amazon, and it represents a vast tropical carbon sink. This Congo Basin, and in particular, the largest region here in this group of countries, Democratic Republic of Congo, have tremendous amount of small-scale agriculture contributing to forest loss and CO2 emissions as a result. Looking ahead, it's really difficult to project the risks and opportunities of our population boom, parallel resource crisis, depend largely on decisions we haven't made yet, which will affect our future more. The billions of mouths we'll have to feed, or the billions more brains we'll employ to help feed us. I thought that was an interesting point of view, more positive point of view, that maybe with more brains we could improve the technology and help to do it. But there are limits still to the materials, of course. So these are positive and negative thoughts from UN experts who are asked to make risks based on decisions not yet made. And the very positive people like Peter that we hope to have heard from at the beginning of this fall, those people would say, well, more brains could help us solve our problems. And some of them are a little bit, they say the brains have already done everything that we need to do for the pandemics, and we won't get any more for a while now that we're taking greater care. That's what I call being very positive. And then they say, well, mass migration will be unlikely before 2050, but 2050 isn't that far away. It's only a quarter of a century, and that's still going to happen, I think, probably before 2050. Then there's some negative thoughts. More mouths to feed would create more famines. The middle one is clear. The wildlife is disappearing at an alarming rate, and pollution, overfishing will harm our oceans. No doubt about those negatives. And then improving access to effective contraception has been, until now, largely ignored by the international climate community. Two people, John Bogarts and Regine Citric-Weyer, claim that improved access to contraception could slow population growth and thereby reduce long-term greenhouse gas emissions globally by 40%. They wrote that many married women, over half in some countries who don't wish to become pregnant, fail to use contraception due to access barriers, such as high costs and social stigma. Consequently, there are about 121 million unintended pregnancies worldwide every year, and some predict that the Earth's population will reach, we already said that, 10 billion by 2100. But there is a positive viewpoint to all this. Peter Fakowski, our old friend who couldn't join us that day, claims that steering humans toward a safe population level can be done by humane, ethical means. And he points out that global birth rates have been falling for 60 years now, and family size has fallen from 5.2 to 2.4. So that's good to notice. While we focus on right to life versus freedom to choose, an increasing number of young couples are choosing to live child-free. And that's something, a quiet thing that hasn't been published or noted very much, but I think it's definitely happening. Note the dramatic influence of TFRs, that stands for total fertility rates, on the projections of future population. Now, the total fertility rate is a complicated number. It has to do with the number of children that a woman is expected to have within her time of fertility, given the other population factors in each 5 years of her lifespan. It's a complicated number, but it works out that if our total fertility rate remains at 2, we'll just zoom up to this high level and stay there for quite a while. But this is a warning, because if we dramatically, in the developing world, cut it back to 1.5, 1.3, we could get right down to they've conveniently put the line here at 2 million, which would be nice, but we don't want it to go any lower than that. And so these are modifying influences that are, we need to be careful that we don't overreact. A lower birth rate will lead to an aging population. Japan is at the top of the list here of areas with the largest percentage of people aged 65 or more. Sorry about this little blocking, but this is 65 or more up in the upper right. So Japan is way out there. And it's kind of nice that they have a strong social ethic for a cultural system for supporting the elderly there, because they're way ahead of there's an aging population, definitely, compared to Italy, Greece, and Germany. The United States is way down here because I think partly our immigration policies are allowing quite a number of young immigrants to come in, and allows us to have remain relatively young compared to many of its peer nations. So as a country, some other countries, particularly in Southern Europe and in Japan, will need to take care with their aging population. What about future projections ahead another couple of 100 years? I'm going to skip this top part of the top and just quote this rather interesting paragraph that I found. Waiting until the population peaks to ask how to respond to depopulation would be as imprudent as waiting until the world starts to run out of fossil fuels to begin responding to climate change. So humanity needs a compassionate, factual, and fair conversation about how to respond to depopulation and how to share the burdens of creating each future generation. And the way to have that conversation is to start paying attention now. So this is 100 million people in 1000 BC. And what concerns me a bit is this other possible scenarios. This could be lower than 100 million. And that's pretty low. Would suggest a very different planet from what we're enjoying now. The other thing is that this could happen more easily than we think. They say most people now live in places with below replacement fertility. Europe crossed that threshold way back in 1975. China in the early 1990s. Brazil in the early 2000s. India only just now is crossing that horizon of replacement fertility. So you have Italy here, Hong Kong, all these countries, and you still have some gray ones here, but unfortunately they're not identified in this picture, but we know where most of them are. Nigeria we mentioned, and the Congo Basin and so on. And these could slip down pretty quickly, and not that we should stop anything, but we should think carefully before we put in massive changes.
Say,
Also,
Richard, do you hear me? This is Lou. Just a comment on a recent National Geographic, maybe 4 months ago or 5, but you had that one slide where Japan had so many senior citizens. The problem with that is, how do you support that one? How do you support them unless you have a working class? And I think what that issue said was you need a working class, like paying taxes, but sort of on that order of 64% of the population, or you can't support all of those older people. And it sort of segues into the last slide you had shown too a little bit. I mean, you can't, if you lose too much population, especially working, then the older population is going to suffer and be unsupported. That's it.
I agree with you, Lou, that you're making exactly the point I'm making. I'm not as concerned about Japan as I am some of the other countries on that list, because Japan has this incredible culture for supporting the elderly. I think that I haven't been to Japan for a long time, and my time there was short as a tourist. But what I've read about Japan is that there is a strong culture there of supporting the elderly, stronger probably than any of the other countries on this list. So, and that's probably why they got such an aging population. Partly why is because they've evolved into this, because they have this this strong cultural support of the elderly. And I think the cultural support is they're living together rather than isolating these people in elder homes. And that may be not so easy for us to adapt to, but I think they've already done that in Japan, and they're ahead of us in that regard. But these other countries, yeah, we're all aging here quite a bit, and I think I'm less concerned about Japan and a little more concerned about the other countries.
Yeah,
particularly,
I think you really answered that well.
Yeah,
You really,
okay.
and I think that's right what I was thinking. Thanks.
Okay, you're welcome. This is an article that I found in The Economist. And it's interesting to look back from today, to look back 30 years or so, to see that unfortunately, they don't have a table showing a key for the colors here, but the size is related to the population is related to the size of the circle. And the color, I think, relates to the youth. And so in India, I think fairly young population. In Brazil, a little older in China, but still no population's terribly old back 30 years ago. Today, we're starting to find an elderly Europe and a more elderly Japan. So that's reflecting today. If you take those changes and project them out another 30 years, 25 years or so, by 2050, they say most of today's richest countries will be old, all through Europe, and of course China now, not just green, but quite yellow like Japan, and so on. That's perhaps Thailand. Anyway, it's an interesting thing, and the economic logic of aging is hard to escape, but my comment is perhaps we should look beyond economic logic and consider how to protect social catastrophes as that continues to happen. Another article that came out, a digital one, shows low fertility over the past 30 years. The trends with wealth, they associate the money. This is a logarithmic plot here in GDP per country, per capita. And this shows the time span of 30 years. And you don't see the beginning. The white circle is where we are today, but there's a huge trend downward, which we've been just talking about, lower fertility, but there's also a drift to the right, and that is that people recognize either cause or effect of a better income, showing that the economics and politics of a society in which the old outnumber the young will make it even harder to choose policies that support children. So a thought there too, how money gets involved. Just some comments. We've seen these graphs before, but they're never hurts to notice them before. About temperatures, we heard about our temperature. I think we exceeded 2 degrees just recently this year, and our global temperatures. And we see it here in the oceans in blue, as well as on land and ice. We see daily sea surface temperatures in July of this year reach quite a bit above the average. So this was global, daily average, and a remarkable increase over the average of the previous 30 years. So that's something to be aware of, that just to be reminded of that as we think about population. So now this is my last slide on population. I sort of put together my thoughts on it, and it's depressing as all get out. What human threats are we seeing already? Are humans an endangered species too? Well, we've seen it. The forest fires in Hawaii, Canada, and Russia are eliminating our natural carbon sinks. This is a potential, I was going to say disaster, but it's a huge problem, because these are natural sinks, and as they get eliminated, it's going to have secondary effects. More intense typhoons and hurricanes contribute to habitat loss. Methane leaks from natural polar sinks are poorly mapped, poorly protected. We don't know an awful lot about that impact in the future as a tipping point. Our electric grids are not as resilient as we thought they would be. unrecognized potential of nuclear fission has hindered closing coal plants. There's no doubt about this, and I'm going to come to it in a few minutes. Failure to stop wars has increased wasteful military destruction and pollution. We've seen that day after day in Israel and Ukraine. Lack of global recognition of our need to act immediately, and there is that lack of recognition, puts us in grave danger. So these are very depressing thoughts, and just as far as I feel like going on the subject, because I want to have be something a little more upbeat. So the other day while I was shopping with my family, I went to the bookstore, and I wanted to see what Greta Thunberg was up to. I admire this woman a lot and her impact on climate change. So I opened this book, and they don't have any chairs in this bookstore. I think they don't like people sitting and reading too much of their books. They just want them to buy them and move on. So I ended up finding a stairway, uncomfortable to sit on. But I wanted to really get a better picture of this book. It's about 300 pages. And I noticed when I did some browsing around that she spent 1/4 of one page on nuclear energy. All of her statements were technically accurate, every one. I could not argue with the accuracy of each statement, but every one of them was very negative. It's too bad that she didn't look across the Öresund Strait from Malmo in Sweden to Copenhagen for a better perspective. And here we go, folks. I'm going to tell you about Copenhagen atomics. I'm not sure if I've mentioned them to you, but it's a group, but we've been talking about them a little bit in our Friends of Fission subgroup. This company started as sharing ideas in 2014, and by 2017, they weren't quite at 75, but they were building up there, and now they're at 75, but they began as an official company in 2017. In 6 years, they have this team. The leader, you'll hear about Tom Peterson, is here, fourth from the left in the front row. They make this amazing claim that $100 worth of thorium fuel can provide all of a person's life energy needs for life. This includes electricity, transportation, heating, all the needs that they have, even those that are integrated with the rest of society. Their portion of it can be paid for by $100 worth of thorium. We haven't heard very much from thorium. It's kind of an ignored atom. I had the pleasure of having an MRI done recently in my spine because of some sciatica recurrence, and my technician was a delightful guy from Finland. His name is Thor, and of course, I had to have a conversation with him about the origin of his name. And partway along, I asked him if he'd ever heard of thorium. He never had heard of it, and unfortunately, I had a little book, a little brochure the Margie Kindig had given me years ago in my briefcase, and I forgot to dig down and pass it to him, and I'm going to try and track him down because I think it's amazing that a guy from Finland with the name of Thor doesn't know about thorium. We need to bring him up to date. But anyway, that's an aside that I just share with you. This is a fascinating company, and I'm going to show a few slides. It's only 20 to 11, and we've already gone through overpopulation, and I want to show you this. We're going to go into it in more detail, and I might get Tom to come and speak to us on Zoom next March. But his message, he's on YouTube a lot. He has these 3 points. First of all, he says we can match anyone else on price. He says we have the lowest price, and he'll elaborate on that. He said there are no taxpayer investments. Copenhagen Atomics Finance build, own, and operate, or BOO. It was originally started by Rosatom in Russia. And not only that, but they also decommission. And they're only talking about the heating part. They leave the grid and the turbines, which are conventional sources of energy if dealing with coal or other gas and other things. And that's up to the host company or country. But what they provide is the heat, and they will do that for remarkably low prices and remarkably quickly. By burning the nuclear waste, it makes 10 times more energy, and he's quite emphatic about that. And also the quality of the waste. The original products had to be stored. The unconsumed, as you know, we only, with light water reactors, consume 2% of the uranium, and 98% of it is still there. by using it all, we change the quality of the waste from something that only needs to be stored 300 years instead of 100,000. And he emphasizes that probably a little more than he needs to, but it is an important point. I've included this slide too. I don't know exactly what these images show, but the point is good. He says thorium is the only element that allows for a breeder reactor in thermal spectrum. Thermal spectrum meaning relatively high temperatures but in the absence of pressure. This means that the power output per kilogram of fissile inventory can beat any other reactor. This is not appreciated because people have just forgotten about thorium. The industry is used to uranium, and they don't want to even think about, it seems, going back to thorium. They've just, it's sort of passé. But they have some interesting qualifiers. The temperature in their reactors are 560 degrees centigrade. This is in a small reactor, 100 megawatt thermal. They use lithium fluoride, the isotope of fluorine being 7, thorium and plutonium. It's unpressurized, and this is key. Heavy water. Heavy water means deuterated water, or an extra, not an extra, but a neutron, along with the proton in every hydrogen nucleus. And of course, you have 2 hydrogens with every water molecule. So, but this is a very good moderator. It absorbs the neutrons rather than bounces them off, and is a really good water moderator, much better than light water. And that's why we use the term light water as opposed to heavy water. The Canadians have a lot of experience with heavy water in their CANDU reactors, and they feel it's definitely an important way to go to increase their efficiency. He said it's hard to conceive how energy dense thorium really is. A lifetime of energy, all for $100 is such a bargain, and they have this $100 worth of thorium in the palm of the hand. This also, they say they can do mass manufacturing, and it's along an assembly line that allows a nuclear power plant to be assembled by robots. No humans allowed inside, just robots, at the rate of 1 plant per day. I find this just mind-boggling. We think of South Korea as pretty efficient at 5 years for a reactor, and they can do 1 day. Build a plant is just amazing, and they'll fit into a 40-foot container. So he's quite emphatic and positive about this. And then he comes across with this amazing slide. The Copenhagen waste burner here has a break in the numbers. Each number, rather than on a key on the side, is posted over the top, comparing solar, wind, gas, coal, hydro, and light water reactors. Look at that compared to the waste burner. He says greater than 10-fold improvement over conventional light water reactors. He also has this little thing on selling points, and he has a jet aircraft over his favorite waste burner, a car over uranium molten salt reactors, and a horse and buggy over the light water reactor. And he talks about the dropping costs. If you can eliminate mining, which you can do when you recycle, it takes 50-fold off of even the molten salt reactor and 100-fold off the light. With no enrichment, that saves, again, a lot of money. The waste storage, you only need to do for 300 years instead of 100,000, so much less concern there. And the energy price, he says, 4 times lower than with the light water reactor. That's a pretty impressive figure. And the deployment speed 100 times faster than with the light water reactor. So these are amazing numbers. It's hard to believe, but you can't say that it can't be done. They're not that far away from doing it. And I'll come to that in a few minutes.
Hey, Richard, this is Doug.
Yes.
I have a
Yes,
question
Doug.
for you. I have a question for you.
Sure.
I would think that something that decays over a period of 100,000 years doesn't need to be stored at all, that it's not dangerous to anybody.
Yeah.
Is that true? Is that true or not?
Yes and no. It is, you don't want to have the enriched uranium that we put into our light water reactors sitting around. Once it's enriched, you have enough. The enrichment is 235. over the natural 99.9% of it is 238, which is fairly innocuous, as you imply. But once you enrich it, it gets enriched greatly, and that does give it risk. So the risk is in what's in these storage tanks. Fortunately, nobody's ever been hurt by them, and they're very strong tanks made of steel and concrete. Nobody's ever been in any way even endangered by them. They're very safe. They can be transported around. But yes, if those things spilled, you would have some serious radioactivity around because of that enriched uranium.
And so, but my question really is, if you separate, and I don't know how difficult the separation is, but if you separated those isotopes that decay so slowly from the ones that obviously are creating the problem, then a large fraction, in fact, I don't know what the fraction would be, but some fraction of that would not need to be stored at all. Is that correct?
Yes, but you'd have to come up with that fraction, and that's not easy to do.
You'd have to come up with the separation technology.
Yes, and you have to, but why not avoid that and deal with thorium? You're actually anticipating a couple of slides from now. And
well,
I'll deal with that.
I'm talking about this one specific issue, and I've heard this a gazillion times, that something's going to be around forever. And, you know, what I know, I mean, just it seems intuitive that if something decays that slowly, that causes something to lay around that long, then it's not really, unless maybe you breathe it in, it probably isn't that dangerous. But then you have to separate that fraction out somehow so as not to need to deal with it. And I don't know what the fraction is, and I don't know how difficult the separation is either.
Well,
and so I'm asking the question. I don't know if you've delved into that at all. It sounds like maybe not.
Give me some time, Doug. I'll come to that question. You're just a little ahead.
Okay, sorry.
Yeah, can I just interject a second? This is Lou. Doug, it depends what it decays into. I mean, if it's decaying into something that's still highly radioactive, and that decays into something that is highly radioactive, then what? If
it's that slow,
that's the problem.
That slow, then it wouldn't make any difference.
There's a point I should mention that plutonium is generated in these reactors. These reactors were designed as light water reactors at Oak Ridge back in 1942, and they were designed to be carried out at Hanford, Washington, because they generated plutonium for atomic bombs. That is not a nice isotope to have around. So I think that your statement that people quote is misleading, and you need to be more specific. And I'll come to it, I think, in a little bit better form for you. But you're just a wee bit ahead of me.
Okay, good.
If I can step in for a second, this is Steve Shellen.
Sure, Steve.
I think you're going down the wrong path. If you have to store radioactive material to protect the population, you're not going to spend the energy to separate it into isotopes that are more dangerous and less dangerous, because it's such a compact volume to start with. You just store it. And some of the more inventive ways to do that is to use oil drilling equipment, drill a hole down into a rocky substrate, put the materials in a container, send it down, and the earth itself changes so much that it will completely seal that in an future attainable location. It just doesn't pay to separate it to get low activity and high activity materials separately.
Thank you, Stephen. You're an expert with all the experience. We need to answer that question. I completely agree with your good reply. Let me let me carry on and we will deal with that. But I think you reflect a very good point that costs are predominant, particularly at a time we were using wartime economics to make as much plutonium as we could. And that's a serious problem. And it's easier now that we have this material around to just bury it. So, but let me come to that, and I think I can help you out a little bit.
Yeah,
Just to deal with this slide, and we'll come to your question again.
yeah.
What are the safest energy sources?
You use the radioactive material to make energy, and then you waste that energy by doing complicated things to extract it when simple burial is
Yes.
cheap.
Yes, that's right. But much better to reuse that material. And we decided years ago not to recycle. Other countries didn't make that decision, but we, according to our priorities, decided that we didn't want to bother recycling, and so we're stuck with material that's only been used 2%, from 3.5% to 1% enriched, and then we just bury it or leave it around to be buried later, and have people, left-leaning politicians like Bernie Sanders say, well, nuclear is no good because it's got all this waste, and people listen to him, and the public thinks waste is a huge problem when it's just a political problem. Anyway, moving on to the safeness. Tom, when he gives his little YouTube talks, he gets pretty upset when he shows this slide because he points out 24, that looks like 246 deaths from coal, from accidents and air pollution, compared to nuclear energy 0.03. So this is 1,000-fold difference. And people in Europe, Poland, for example, and other countries, and he makes a little dig at Poland at one point, that they're trying to make a decision whether to use coal or nuclear, and he can't understand how anybody who sees data like this can even have this discussion when you have 1,000-fold difference between coal and nuclear energy, and they're not sure which way to go. This just, you can tell this really bothers him, and I can see when you look at the data there, it's amazing that people say that nuclear energy is dangerous. When you look at the history, 60 years of history, this is not just 5 or 10 years. Okay, coming now to the recycling issue, which I think will help us deal. This is this new used nuclear fuel. It's 95% uranium is what we're dealing with today, and it's in these casks. And that 95% uranium can go on the market if we can find a market for it. Now, you can find an easy market for it if you have these thorium reactors around, because it can be mixed with the thorium. The thorium in itself is fissile, but not, I'm sorry, is fertile, but not fissile, which means that if a neutron comes along, it can fission. But by itself, it's not a very efficient fissioning isotope. And so it needs a bit of uranium to get it going. And people view that, some people do, who are negative about thorium as well. You've got to put some uranium in. Well, sure, but there's an awful lot of it around. And sitting in these casks, 95% of it. This is after it's been used for 4 or 5 years, however long before they recycle the materials in the reactors, light water reactors. So the 5% that is over here comes out to 4-to-1 ratio. The 1% is the plutonium and long-lived actinides, and they need to go through and be consumed in the thorium reactors. The 4% can be stored for 300 years, and that's the 300 as opposed to 100,000. So that is their idea of recycling nuclear fuel, that this will now enter the market, because with thorium reactors, there will be a market for uranium, more than there is now, because we'll have, if he's generating one of these thorium reactors every day, there'll be lots of them around that will need to be primed with uranium. Also, he says there is enough thorium around and enough uranium around both to provide energy for the world's energy needs for thousands of years. And he has a typical amount of 300 kilograms, or a third of a ton. And he takes a ton of thorium, mixes this in, this used nuclear fuel we were talking about. So they have 1.3 tons. And you can put that in this reactor, thorium reactor. He calls it powered by stardust. And then from there, you can produce energy for making hydrogen, synthetic fuels, seawater desalination, for industrial heat and district heating, and of course for electricity in the grid. So, and you end up with some fission products, but it's a lot of recycling going on here. He talks about developing these reactors based on molten salt reactor with the same footprint as a 40-foot shipping container, which delivers 100 megawatts of thermal energy per unit, expected to reach an electricity price, levelized cost of electricity below $20 per megawatt hour in a mass manufacturing scenario. He says this waste burner is expected to be online in 4 years and will run in a combination of thorium and used nuclear fuel, reducing the storage period of the existing nuclear waste from 10,000 to 300 years. And the expected, they're already in the process of building a non-fission prototype for this 1 megawatt demo reactor, which will validate the design using non-nuclear fuel salt. So that's his points on where they are gone so far. This is what one of his plants will look like. This will have 25 of these reactors all in a row here, along here, and he'll have a few extras for reserve. He said only robots will work in these reactor rooms, so no human errors can occur. And then, yeah, finishing with this little joke, and then we'll get back to nuclear energy. This tough guy on probably Fox News or something says, our guest today is Gaia, the Earth goddess. And he says, so Gaia, how about this global warming hoax? Aren't we just fine if it gets hotter? And she says, oh, it's no problem for me. I've been hot before. And then she tickles his chin and says, it's you humans who'll have to find another planet. I thought that was a good joke. Here's a more serious note about Albert Einstein and a quote that he made in 1954. He said, a human being is part of the whole universe, a part limited in time and space. He likes to think about time and space. We experience ourselves, our thoughts and feelings, as something separate from the rest, a kind of optical delusion of consciousness. This delusion is a kind of prison for us, restricting us to our personal desires and to affection for a few persons nearest to us. Our tasks must be to free ourselves from the prison by widening our circle of compassion to embrace all living creatures and the whole of nature and its beauty. We shall require a substantially new manner of thinking if humanity is to survive. I know not with what weapons World War III will be fought, but World War IV will be fought with sticks and stones. Sort of an unfortunate last sentence, because poor Albert didn't know back then what we know now, 70 years later, that we have survived I think, and I don't think it's a major threat that we will destroy ourselves with nuclear weapons. I think we recognize the danger and have done pretty well without it, using nuclear warheads, although we built them. You may know, I think I've mentioned this before, that when the USSR collapsed, we bought their warheads and powered our nuclear reactors for about 10 years with their highly enriched uranium and plutonium in those warheads. So we did them a favor for a while. Unfortunately, now we're dealing with a carryover from World War II and the head of Russia, who is creating a lot of unnecessary stress. And unfortunately, I think this delusion is, although present to some degree, I think we have demonstrated a widening of our circle of compassion to embrace all living creatures in Ukraine, in Israel, in Gaza, and around the world. And I think that's showing up in our news and our political stance today. So it's an interesting quote from Einstein, but I think we've done a little better than he thought we might. So now I'll open it up to questions. And this one seems to be the big issue, but it's just 11 o'clock. We're doing fine and lots of time to chat.
Just a comment based on what Doug was saying. You have to know the half-lives of this one, this remaining waste that you're talking about.
Yes.
These remaining wastes that you have, the 1.3 tons or whatever, you have to know the half-lives, and you can't factor any of this with, because if you have a 10,000 year half-life, that's going to really stretch things. It's not just the rate, it's the half-life that it's active. Right?
I should have perhaps put that in, Lou. It's a very good point. Steve did give us that information in his little paper that he sent around. But it's hard to remember all those half-lives. I have a hard time remembering just a basic few.
Well,
but
in spite of that, Richard, the half-life and the rate, they're one and the same thing. The half-life is very long, the rate is very slow, or vice versa.
Yep.
My question really pertains to, hey, there is a fraction of that waste, and I'll do the calculation myself. I'll find out what it is, and then I'll give it back to you.
But I think that whatever the calculation, I think
It's easy to do.
Stephen hit the nail on the head. It may be easy to do, but you have to have a government which has been overlooking all this time, particularly the Nuclear Regulatory Commission.
I'm not proposing a solution, Richard. I was just simply asking a question.
Okay.
And I wasn't saying it's economically feasible or even desirable.
Okay.
I'm just asking a question, and
okay.
I think that you've presumed something in my question that I really didn't intend to convey.
Well, I did presume, and it was because it sounded like somebody who was trying to defuse the problem without considering the reality of economics. But you're absolutely right. That's why I said yes and no.
If there's one person in this group who's concerned about economics, it would be me. I've told you before, I'm a cheapskate, and it's the first thing that enters my mind in anything that I think about. But that's not really what I was asking about.
Okay, that's fine. Well, as I say, that's why I said yes and no at the beginning. It has some reality. If you're willing to pay the money, you bet. In fact, I'm going to be talking a little bit about this next spring in reviewing the first nuclear era by Alvin Weinberg. He was very aware of this. He made this statement that thermodynamically, you're going to have either a very, very slow leak that can be managed that would affect a few people, or spread in the air that would affect larger people but wouldn't be nearly as toxic. And so so you're not going to have both. You're not going to have large exposures with largely highly radioactive materials. It's either going to be highly radioactive to a few or very low radioactivity to larger numbers. And so that pretty much fits with what you were saying.
If I could interject,
Stephen, sure.
the problems in both pollution and waste storage of materials and garbage, we have a mindset that the pollution solution is dilution. And we dump
Yeah.
our garbage in the ocean to dilute it. We do all sorts of things like that. Regarding nuclear material, if you're not going to use it, the cheapest way, being a cheapskate also, is simply bury it. And it doesn't have to actually be buried very far. If people are stupid enough to get and want to dig it up and die, that's another solution. The people who want to do bad things with it just won't last very long. I don't know if that's pragmatic or just common sense. And the other thing is, if we look back in our human history, we were surviving in parallel with all the animals, all the creatures in land and sea, when we did not have, quote, civilization. It's civilization which has brought people into close contact and into conflict that has been our problem, because we are very selfish and we want the best for ourselves, others be damned. It's, I don't know how to say it any better. It's just a human problem that we want to be better than other people, and our pride is hurt when that's challenged.
Thank you for those interesting thoughts. I think that you're making good points there. On top of that, there's an overlay of the linear no threshold hypothesis, which says any amount of radiation is bad for you. And the reality is that we evolved in an environment where there was a lot more radiation around us than there is today. And we have radiation repair enzymes that are working in our bodies all the time. And the evidence for those exposed to low dose radiation in the workplace has generally been favorable. And some people have even gone so far as to prescribe the idea of radiation hormesis, but a little bit of radiation is actually good for you. In contrast, PFAS and lead and all kinds of other things in our environment are getting far too little attention, in my opinion, and need to be investigated more, particularly PFAS, to find out how much these things are really contributing to illness, and fixate less on radiation, which I think is the fear is way overplayed in the public mentality.
If you go outside in a sunny day, radiation is there. That's what evolved us.
Yeah.
Just a quick point. I'm going to make two quick ones. I think the thorium reactor tends to get rid of the long-lived radioactive waste materials. It seems to burn those out. So you're going from 100,000, 10,000 years down to 300. I've heard this at Argonne for years, that's kind of what some of their processes did. But this is a reactor doing it, not what they were working on. The other thing I have is this idea when you mentioned earlier about mass migration. This one, I forgot the agency saying it won't happen for 25 years or more. Everything I've heard, it's not the case. That mass migrations, well, it depends how big mass is. If it's what is the size of a mass migration? I don't know, but migration pressures are going to be building very quickly, I feel, with populations.
Yes, I agree with you totally. It's a very good point. And well, we see that on the people crossing the Mediterranean on these rafts. What's tragic is these people are spending their life savings and then drowning in the Mediterranean. It's a dilemma, but it's starting now. And I think what you're saying is it's only going to get worse. How rapidly it'll get worse, we can't project, but it is a problem for the future. I would like to mention at this point, think a little bit about next spring. I have an agenda already prepared. It's still a few uncertainties before I send it off to you. But starting on February the 19th, I will be reviewing Alvin Weinberg's book, The First Nuclear Era, because I think history is really important in this, and it's something that we can all benefit from reviewing. I would like to get your feedback, probably not for next spring, but possibly for next fall. And Tony Praza has been good at sending around something. I might be able to pull out something and send it around to ask you to give a little check mark on things that you'd like to see more of, or other things less of. People say that maybe there's a little too much emphasis on nuclear things in this group, but you can see my emphasis is clearly reflects my bias, my personal bias, that it is the one technology that can help us get rid of coal plants. And coal plants, I think, are really need to be stopped. And our efforts so far have been pretty pathetic. Either replacing them with natural gas, which just delays the issue for 40 years or more, or what they're doing near us here in Madison is they're putting some kind of a CO2 pressure dome in place at the Columbia Station and near Portage, Wisconsin. And this CO2 under pressure is supposed to act like a battery and would help us during tough times. It might turn out to be a satisfactory arrangement. I'm not sure, but it's a shame that we do not have a few of these lovely little thorium reactors to put in to replace that coal plant near us. They are going down in other places along the east coast of Wisconsin. Some of the coal plants are coming down and elsewhere. But I view it's one of the things that high tech can help us, along with the whole bunch of other things that I was mentioning in that rather depressing last slide. So that's partly why I'm emphasizing nuclear, and also because it's poorly understood. And I think our group is valued by other people who like to come in and say, oh yeah, you are pretty bright and you ask a lot of questions. And he says, I really like talking with them. So we have a nuclear things plan.
Richard, you have a couple of questions on deck that you may want to look at.
Thank you. Thank you. I will check that now. Bill Gates says Lee, in one of his TED Talks, that if we do a good job with the vaccines, we can. Is there somebody talking in the background? If I can just read off this question
that would be Stephen needs to mute. Stephen needs to mute. There we go.
Okay. Bill Gates said in one of his TED Talks that if we do a good job with the vaccines, we can reduce the population by 10 to 15% or so. And indeed, post-COVID vaccine rollout, the life insurance companies reported an increase in all-cause mortality rate of 40%. I'm not sure where you're headed with that question, Lee. Can you comment a little bit more?
Yeah, I'm just saying that that there is going to be a big drop. There is currently a big drop in population, and I think that the concerns are actually Elon Musk said that he was more worried about a population collapse, that we weren't keeping up enough. In like a lot of countries, as you mentioned, we have aging populations, and especially like Japan. So I'm just saying that maybe the population explosion is going to get reversed. Also, we're looking at a possible World War III, which will also, if they get out the nuclear weapons, I don't think we're going to have to worry about it much longer. Unfortunately, in a bad way, if you know what I mean.
Good. I'm glad you say that. I think I have to agree with Bill Gates that we're doing a good job with our vaccines, but that little blip you saw in the curve, I don't think was reflecting so much COVID effects, although people were staying home, and I think that's reducing transportation quite a bit. So that's definitely a good thing. The use of Zoom that we're doing now. I used to enjoy driving into Oakwood West, and a number of you folks did. But boy, it's so easy to do this from home. And although I miss seeing you all, and vice versa in the group meetings we had at Oakwood, it sure is convenient to be at home and sipping on a coffee or something like that while we're watching a program and conversing. So it's I think what you and Bill Gates are thinking of are the very tiny percentage of people in the developed world who are increasing the population, but we still have vast numbers of people in the undeveloped world who are not that affected by the pandemic, amazingly and fortunately. But so I don't think that that's much of a blip. However, I do agree with both you and Bill that we need to be aware of going overboard and in population dropping, and that was the whole thesis of my talk this morning. So a good point. Let's see if we have any more questions here. Alan said, I've heard that educating women in poor countries dramatically reduces birth rates. And I think that's true. Particularly Pakistan, I mentioned that also, in India. It's very true. And when I went to Ethiopia, that was some time ago, a couple of decades ago, there were signs everywhere in Ethiopia about educating women, everywhere we went. So it's definitely happening. Good point, Alan. Well, anyway, I was just getting to the last point that I would like to send out a survey. Would appreciate your suggestions, not only for topics, but if you yourself would like to lead a discussion, we can always go back to one of the methods we used back in 2010, 2011, which was to pick a subject, do some background preparations, but just have a group discussion. And I think Dottie did this a while ago, talking about biodiversity. We were all given a bunch of things to read, and then we just contributed to a group discussion rather than have a formal presentation. And that's a great idea, and I think we could do that also. But I need your input, so I'm going to send around over the winter holiday a blank sheet, and maybe you could just fill it in and then send it back to me digitally, and or in the mail, whichever you like. And I could try and use that in perhaps modifying a little bit the next spring's course and the next fall's course. So any other thoughts?
Richard, I've
Yes.
got a slightly related but maybe group size question.
Sure. This is Mert.
Correct. This Merck. The Elon Musk electric cost reducer device, if that is anywhere near realistic, does that mean that we are, and he's talking like a 10x reduction in your electric cost, does that mean that we would then, as users of that, be using 10x less electricity? Is that a device to actually end up significantly reducing electric usage? Anybody know?
Can you elaborate on what you're talking about, this electric usage device? Is it a battery you're talking about, or what?
No, this is a device you plug into your electric system at your home, and it reduces the form factor of the electric coming in, and you use much more effective use of the electricity brought into your home, and you then it reduces your electric bill. So it says by 10x. Anybody? I mean, it's out there. They're readily available. It kind of looks like almost like a detector you plug into your wall. You plug it in.
Like this is
anybody
Doug.
know how that works?
It sounds like I can't believe it's 10x, but you know, when you run motors, you have I can't remember exactly, you know, I'm going to wave my hands here a little bit, but you have a change in the phase alignment of the current and voltage or something like that, and you actually get charged for a little bit more power because of that. And what they typically do, in particular in big plants that have lots of motors, is to put a big capacitor in order to align the phases better, and that lowers their energy cost. I'm guessing that's what this is, but I have no idea what he's talking about, really.
By its size, it would be implied that kind of a phase form factor reduction. But
yeah, plants that have lots of motors in them obviously have big induction loads, and then the you know, they have to pull more power, and then they return it later or something like that. I have to go back to my my books in order to explain it better, but I know that those kinds of plants put a big capacitor on the wall or whatever to offset that, to lower their costs.
That's what it looks like.
But again, I'm not sure. Size. I'm not really. I have not read anything about what you've just mentioned. So I really don't know.
You know how much it cost, Mert? What was the cost?
If I can step in a bit,
go. Yeah. Shoot away.
Having spent some time in the electric utility industry, Doug is very correct. What you're doing is changing the phase factor so that the use of the electricity is more efficient. And when they're talking about your home, you're talking really about three things: your refrigerator, your air conditioner, and the motors that run your heating system. There are not many other things that can change the alignment or phase factor outside of those. And as we change from incandescent to newer lighting systems, the costs should go down. But because most of the cost is based on the system, not necessarily the electricity itself, but the distribution system, I don't see that is going to make a major thing that's going to change our costs. It may change the amount of electricity used. And I myself have a couple capacitor items that are on my system at a building that I own and rent out offices. And I have 12 air conditioners, and you need to be aware of the fact that they're all trying to do different things at the same time. So I have some capacitors that are already on the market, and it doesn't do a lot, but it does a little.
Does that mean that you're actually using less or just being charged for less?
You're using less.
So that's an interesting option. Interesting.
But it's not a huge change, not a factor of 10, I can tell you.
Yeah, you wouldn't expect. Surely Musk has given you the truth, right? he wouldn't stretch the truth on us, would he?
Right.
So again, I don't know what he's referring to. I haven't read this article, so you know, when you say I'm exactly right, that's probably not true.
Does the phase change the total amount of energy that's needed? I don't understand that at all. I mean, I'm not an electrical engineer, but
yeah, well, you can read that. You can read a book, and you can go and read about it pretty quickly.
What's the name of a book? Can you remember?
Just actually look up. Just do a Google search on something like phase change, induction motors, condenser, and you'll find an article on it, Lee.
Thank you.
Mert, could I ask you how much this thing cost? Is it available for sale or what?
The ones for your home?
I'm asking Mert. Mert brought this question up, I believe.
Yeah. So I'm kind of just doing a quick check. The answer is for senior citizens, it's almost a giveaway. Let's see, here it is. Limited time offer, 50% off. Let me get something. Yeah, no, I don't want to do that one. He calls it
sold by a Nigerian prince by any chance?
he calls it Stop Watt, STOPWATT. And of the, what is it? Of the 13,000 users, it's got a 9.9 rating.
Oh, there you
Star
go.
rating. So let me see what else we know here.
You're 50% off of what is my question.
Yeah, I know. I'm trying to limited time offer. I'm probably
If
going to
you
have.
God.
I'm probably going
If
to
you
have
don't
to.
mind,
This is a scam.
you don't mind, you can give us a report next spring.
Yeah, well, if it
Sounds
really
like a
works.
scam to me too.
So yeah, for instance, on his website, he shows $250 a month turned into $25 a month. I have no idea the reality. I know the. Yeah, enough on all that. Anyway, so nobody's familiar with that. That's okay.
No, I think you met with a good deal of skepticism, but if you feel like investing, we would encourage you to tell us about it.
I'll search it out a little bit more. Okay, I thought
Okay.
maybe surely out of this group, I figured somebody would have. I mean, it's all over the internet, and
Yeah, I don't, like I said, I have some in my building.
yeah,
It makes a small change. We have, for example, Door County, where I happen to have a condo. Electricity that goes to Door County goes a long way, just a straight line up through a very unpopulated area to a populated area at the end, the tourist area. And along the way, if you drive on Highway 42, you will see occasionally up on the poles on the line, the main line that's going up there, you will see a set of capacitors that are doing exactly what you said, Doug. And that is what you can do a little bit in your house, because you put it nearest your incoming electricity, and it helps for motors, basically. Other things don't really make a phase change, and they're not effective for something else. I've got 12 air conditioners spread about a 2-story building, 20,000 square feet, and I don't see a lot. I see a little.
So I just Googled this, and I'm looking at an article right now that says, and I'm going to quote from the article. It reflects our skepticism. It says, but a recent Reuters fact check, and there is a link to it, says there is no evidence the billionaire is selling an energy-saving device, contrary to those social media posts. We checked with the electric industry and saw similar skepticism.
Sounds like Elon, or somebody using his name. You know, his name gets bandied about so much. His stocks are down. I'm not surprised why.
Well, no, it implies that what I'm reading here says that he has nothing to do with this.
Well, yes, exactly. But that's my point too. His name has gotten associated with so many gimmicks.
Yeah.
Probably without permission.
He's earned his reputation.
Yes. Okay. Well,
one item along this vein.
Yeah.
Has anybody heard of Ting? Ting? It's a module you plug into your home system, and it's remotely monitored by a company that basically detects faults, sparking, those sorts of things in your home, and it's a good fire prevention type of device. Many insurance companies provide it to their insured because it helps reduce their cost claims. I have State Farm insurance. They provide me with that, and I get a check on my electrical system on a monthly basis, and they put out a newsletter. The Ting company puts out a newsletter of instances where they have detected remotely sparking in homes. They call the homeowner. They provide assistance with a local electrician, and have basically saved a number of homes and maybe lives when their remote monitoring information has proved correct. And it's a simple module that you plug into the wall.
Very good. We'll keep an eye out for it. Thank you, Stephen. Any other thoughts out there? It's 11:30. Time for any more thoughts? Otherwise, we will wrap it up. Wish everyone a happy holiday.
This is what Ting looks like.
Can I mention Merck's talk? I mean, any kind of an update on AI. There's so much stuff happening with OpenAI right now, but next spring session, that Merck could just update us on some of that, be awesome. Thank you.
And Ting is out of Whisker Lab. That's, let's see here.
That's exactly what the devices look like on their website. Looks just like that, Stephen. So
Yep.
my greater concern is that it becomes an internet link to your house and somebody's monitoring you. Maybe Musk.
Well,
or someone equally unfathomable.
State Farm Insurance provides this to me free. And I've read some of their event responses. I think it's worthwhile. I haven't paid anything for it. It may use a little electricity, but maybe I can offset this with the other Elon Musk item.
Not.
That sounds like a more practical, attractive device. I'll check into that too.
Yeah, State Farm paid for it. I didn't pay a penny. So
That's it.
if you get any other information, let me know.
All right.
Good.
So I guess looks like we're shutting down here, Richard.
Okay, sounds like it. And I've enjoyed the conversation. Provocative as usual. And again, I wish you all a happy holiday season, and we'll look forward to getting together in mid-February. And I will be sending out a survey to see if you have any suggestions for group discussions, presentations, field trips, etc. And I think Lee is already working on a field trip for us in the spring too. So thank you.
I haven't heard back from Brian yet, but I may have to phone call him. Sometimes emails get buried.
Okay. Thank you, Lee, for that.
Yeah.
And all of you for your contributions today. And we'll that will be, of course, recorded and put up in the PLATO Madison website. And then we'll look forward to getting together next spring for some similar discussion groups.
I don't know if anybody tried to look at the recorded AI presentation. CBS rejected it because I included 60 minutes video, which is copyrighted. So Stephanie's trying to sort that little mess out with how to deal with that. So if you try to call up that recorded message, recorded presentation from 2 weeks ago,
Okay.
you'll stumble into what happened. That's what happened.
Okay. Thank you for that.
Other than that, as we go into winter, try to stay vertical, no slipping on the ice and breaking these aging bones.
Yeah, Merry Christmas to all.
Yes,
Thank
Merry
you.
Christmas, and thanks for another great semester, Richard.
Yes.
You're welcome. My pleasure. Look forward to the spring.
Happy
Bye-bye.
New Year too.
Bye-bye.
Best wishes.